Yeah. Yeah, good evening everyone. So in the last class just I was discussing about Hadoop architecture, storage and processing. Processing architectural components, we have got job tracker and task tracker. Job tracker resides within the master node, task tracker within the slave node. Okay, we can have multiple task trackers. Okay, number of task trackers equal to number of data nodes. Number of task trackers. Number of data nodes. Number of task trackers equal to number of data nodes. Okay.
Hello.
Yes.
So yesterday I not joined this class.
Your name?
Satish.
Okay. Previously, did you attend any classes?
Yes, I attend the first, second, and third. Fourth demo is not attended.
Okay, fine.
You will now post that video.
In the YouTube, it's there, right? Yesterday's a day for us. Okay, 1 second. Let me check. Okay, this is my master. These are my slaves. S1, S2, S3. S1, S2, S3. Slave 1, slave 2, and slave 3. And here, this master node. These are slave nodes. So processing components, we have got within the master node, we have got job tracker. Within the data nodes or slave nodes, we have got task tracker 1, task tracker 2, task tracker 3. So how many slaves? Those many task trackers. If 4 data nodes, 4 task trackers. Yes. Fine. Okay. Number of slaves equal to number of task trackers. So job tracker assigns the task. Task trackers executes the task. T1, T2, T3. Job trackers are going to assign the task. Task trackers are going to execute the task. Okay. Job track. Okay. So if multiple tasks are executed by multiple task trackers, if any if any one of the slave goes down, then the task of the slave will be assigned to any of the task trackers by job tracker. Job tracker is going to take responsibility of all the task related and processing related. And for storage related, name node takes the response. Okay, fine. Now, job tracker responsibilities. Job tracker response. So name node responsibility storage related, and for task related, job tracker takes the responsibilities. Job tracker responsibilities. First one, who are going to assign the task? Task assignment. Task assignment.
Master dot.
Load balancing. Fault tolerance. Fault tolerance means if multiple tasks executed by multiple slaves, if any slave goes down, then the task of that slave to be allocated to any of the other slave. Who does this? Job tracker. Health monitoring. All this taken care by job tracker. Task tracker responsibilities. Executing the tasks. Given by job tracker. Executing the task given by job tracker, and once the tasks are completed, once the task is completed, gives acknowledgement to, once the task is completed, gives acknowledgement to
Job tracker.
job tracker, right? Okay. Next, task tracker sends heartbeats. Task tracker sends heartbeat signals for every 3 seconds to job tracker. Okay. Job tracker responsibilities, and these are task tracker responsibilities. So in here I've got some queries here. Yes, question. Who is the master? Who is the master for storage? Yes. Who is the master for storage? Name node, right? Next, who is the master for processing? Yes. Who is the master for processing?
Data node.
Data node.
Data node. Why it will process? Who is the master? Who is going to take the responsibility of processing? Job tracker.
Job tracker.
What are the processing components? What is our discussion now? Processing architectural components for processing, job tracker and task tracker. Name node, data node, nothing to do with processing. They are going to name nodes divides that file into blocks, and the blocks are stored by the data node. Data node work is only to store the. Yesterday I was saying about that. What happens? Name node responsibility, data node responsibility. Yesterday I was saying, right? What is name node responsibility? To store the physical memory locations of the blocks. Data node responsibility only the storing HDFS blocks of a file, not for processing. Processing everything they can get by job tracker, task tracker. Who is the master for processing? Who is the master for processing means job tracker.
Job tracker.
Who is responsible for dividing a file into blocks?
Job tracker.
Task tracker.
Who is responsible for dividing a file into blocks? File into blocks.
Job tracker.
Task
What is it?
task tracker.
Name node. What is that? Name node. File dividing into blocks and storing across the slave machines means storage related or task related. How come job tracker store the block? First, whenever you see, is it task related or storage related? Is it processing related or storage related? You need to see. If it is storage related means storage components will take care. If it is processing or task related means processing components are going to take care. Who is responsible for dividing a file into blocks? Name node. Who is responsible for dividing job into tasks? Who is responsible for dividing? Job tracker. Job tracker is going to divide the job into tasks. Who is responsible for storing the actual data blocks? Who is responsible for storing that data node, right? Yes. Who is responsible for executing the tasks? Who is responsible for executing the tasks?
Task manager.
Task tracker.
Pardon?
Data node.
What is it? Responsible for executing the task. Yes.
Task tracker.
Yeah. Task tracker.
We.
Who is responsible for assigning tasks?
Job
Who is
tracker.
responsible for assigning the tasks? Yes. Job tracker. Who is responsible for handling fault tolerance?
Job tracker.
Job tracker, right? Who is responsible in the absence of name node?
Secondary name node.
Yeah, secondary name node. So yesterday I discussed about secondary name node and it's how it is different from name node. Okay. Yeah, 1 second. 1 second. Okay, understood, right? So anything related to storage, name node and data node, and anything related to processing, job tracker and task tracker. There are two types of requests. There are two types of requests. Storage request and processing request. First one, storage request. If any storage related requests, if any storage related requests If any storage related request, first the request will be forwarded to first. If any storage related request, first the request will be forwarded to name node. First the request will be forwarded to name node. And name node should perform the following. Name node should perform the following. And then name node should perform the following operations. If any storage related request, first the request will be forwarded to name node, and then name node should perform the following operations. First the request will be forwarded to name node, and name node should perform the following operations. First one. File size estimation and blocks estimation. File size estimation and blocks estimation. Second, file size estimation, blocks estimation means f1.txt, for example. (192 MB), assume. Number of blocks equal to number of blocks equal to 192 by 64, 3 blocks. Means 3 slaves required, right? If 3 blocks means how many slaves required? 3 slaves required. Number of blocks equal to 192 by 64, 3 blocks. B1, B2, B3 means 3 slaves. Space availability check. Space availability check. Yes. Whether the space is available. Okay. The slave nodes. Within the slave nodes. Next, selecting appropriate slaves for storing the blocks. Selecting the appropriate slaves. Selecting the appropriate stores for storing the HDFS block. Okay. So there are two types of request I said, storage request and processing request. Storage request first goes to name node, and name node performs three things: file size estimation, block estimation, space availability check within the slave nodes, and selecting the appropriate slave for storing the HDFS block. Now, processing request. The processing request will be forwarded to job tracker. JT. And then job tracker request for job tracker request for job tracker request for metadata to name node. Once it is provided, once it provides them, Okay. Job tracker request from metadata. Once it is provided, then the job tracker divides the job into tasks and assigns to job tracker divides the job into tasks and assigns to multiple task trackers. These multiple task trackers and this multiple task trackers executes job tracker divides the job into tasks and assigns to multiple task trackers, and these multiple task trackers parallelly. First the request goes to job tracker then requests for metadata to name node. Once it provides, then job tracker divides job into tasks and assigns to multiple task trackers. When multiple task tracker executes these multiple task trackers executes the tasks parallelly. Okay, this is what processing request. Next we are thinking we have got like you need to answer me case 1. I'm going to discuss 2 cases here. Case 1. Name node running job tracker down. Name node is running, job tracker is down. Name node is running, job tracker down. Now try to say what is what happens. Can I perform storage and processing operations here? Partial cluster services down. Here partial cluster services are down. Means what services are down? Partial cluster services down. Here we can perform storage operations. Here we can perform storage operations. Here we can perform storage operations, but we cannot perform processing operations, right? See, name node is running, job tracker down means here partial cluster service. Here we can perform storage as name node is running, but we cannot perform processing operations. So here we observe the following. Okay, so here we observe the following. If name node is running, see name node is running, but job tracker down, what we can perform? Storage we can perform, processing we can perform. So here we observe the following. See what we can, the running jobs. Running jobs will be terminated. Running jobs will be terminated. New jobs can't be submitted. 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 Submitted. Next. Queued jobs will be terminated. If any jobs are in the queued jobs, means what all the processing related running jobs or queued jobs or new jobs, all these are not going to, queued jobs will be terminated. Okay, these things. What is queued jobs means? See, for example, waiting jobs, the jobs are which are in the waiting state, which are in the queue. Huge jobs will be terminated. Okay, fine. Now case 2. Observe this case 2. Name node down. Name node is down. Job tracker running. Now try to answer for this. Yes. Name node down. Job tracker running.
Entire cluster will be down.
Exactly. Entire cluster will be down. Name node down. Job tracker running means entire cluster will be down. Entire cluster will be down. Here we cannot perform. Here we cannot perform any storage or processing operations. Here we cannot perform any storage or processing operations. Here, for example, I've got a question here. A job tracker is running. Why processing operations cannot be performed? A job tracker is running. Why processing operations cannot be performed?
Once the task submitted, then job tracker uh, request for the metadata from the name node, right?
Yeah, exactly. So here, why here job tracker is running and why processing operations cannot be performed? Here, job
Okay.
to process. Here, job tracker to process. It requires wait. So here, job tracker to process. It requires input file metadata. A job tracker to process it requires input file metadata. Which is available with name node. But name node is down. Which is available with the name node, but name node is down. A job tracker to process it requires input file metadata, which is available with name node, but name node is down. So job tracker. So job tracker cannot process. So here also the following observations can be made. Here also Here also we can make the following observations. Okay, the same thing. Running jobs will be terminated, new jobs can't be submitted, queued jobs will be terminated. Okay, right? So now based on this, try to say first case, name node running job tracker down. In the second case, name node down, job tracker running. Here storage you can say, running jobs you can say, new jobs, queued jobs. Running jobs, new jobs, queued jobs. Storage here, running jobs. No. Here, the second case, storage no,
No.
running jobs no, new jobs no. So here, in the first case, so here in the first case, partial cluster services are down. But in the second case, entire cluster is down. So here, SPOF is it name node. What do you mean by SPOF? Single point of failure. So here SPOF is at name node. SPOF means single point of failure. Single point of failure. SPOF is in a Z name node. That is single point of fully Z name node. That is, if name node is down, single point of failure is at name. If name node is down, then but from Hadoop, okay, Hadoop 2.x, but from Hadoop 2.x version, it is SPO free articles. Understood, right? What happens if these are down? So there are two types of requests. What happens? Okay, fine. Understood, right, everyone? Any queries in this? There are two types of requests: storage request and processing request. I said, right? What happens to storage and what happens to this processing request? Yes. Yes, we'll do one thing. Yes, all that recordings will be forwarded to you. Yes. Fine. I think nobody has got that videos till now. You will get the videos. You can go through the test. Okay, fine. So for today, I'll stop here. We'll continue it. And one thing, the videos and also everyone. Okay. The notes also I'll be forwarding you. Okay, 1 second. You can go through that video in the notes. And tomorrow, like Saturday, right? Tomorrow, Saturday, there is no session for this week. But next week onwards, we'll try to have a session. We'll meet on Monday again. Right? Okay. Meanwhile, you can go through the videos and these notes. Right? Okay. Yeah, in the coming weeks, yes. Once we enter into the practicals, we'll be having some bigger sessions. Fine. Once we enter into the practical part, yes.
So today only you are sharing these notes, right?
Notes, do one thing, everyone. Just forward your mail. Just type your mail IDs now itself in the chat panel.
Okay.
So from the starting, what we discussed, starting from this, how to configure this block size, replication, design principles, how exactly data stored and processed, and ecosystem components, databases, two types of nodes, master and slave nodes, Hadoop advantages, drawbacks of databases. Fine, everything I'll be sharing you. Yes.
Hello.
Yes, go ahead.
Yeah. Along with notes, you can videos also you are sending, right?
Yeah, are you just are you forwarded the mail IDs? Yes.
Yeah, I send the mail ID.
So for the mail IDs, you will get this much, and the videos will be getting to your Google Drives. Everyone will be getting to your Google Drives. Okay, fine.
Hi, Professor. I didn't get that. So can I drop my email ID here?
Yeah, you can drop here.
So I'll be getting the material for this email ID, and this for this Google Drive also I'll be getting the videos, right?
Yes, yes.
Okay, so you'll be sending me the link. Okay. So when
Yeah,
can I?
yeah. And you can just go through this, everyone, tomorrow and day after tomorrow. From Monday we will go with that, and Monday I'll be demonstrating about the software first. I will be demonstrating about the software, and from Tuesday just I'll be going with that. Monday or Tuesday will be going with, first I'll go with the basic commands of Linux, later I'll go with HDFS commands, next we'll go with the practical part of that map reduce, like step by step we'll be discussing, right? Okay, fine. So Monday I'll be demonstrating. By Tuesday everyone make the software ready. If you have got any queries, you can ask me in that Monday. Fine. Meanwhile, you can just go through all that videos what we have discussed till now, tomorrow and day after tomorrow. Okay, fine. So I'll stop here. We'll continue.
Thank you.